Okay, so just see my face and later on just imagine it because I'll be sitting here and demoing everything. Okay. So yeah, so these are the slides, but if you want to go along or just watch out for the transcript, then I have added my link over here, and later on, sorry. Okay. So later on, if you want to get these slides, I'll be updating it on this particular URL only. So if you just want to copy, or I'll just keep it right after the complete session. So yeah, I am Hardip Patel, and just a second. Okay. So I'm not good with introduction, so I just made a slide out of it. And so I'm a backend heavy full stack developer, and I work on PHP, Laravel, most of the time on Laravel, and some of the time on WordPress. I know it's stigmatized, I guess. So in the spare time, so everyone has their side projects, and currently I'm just focusing on one project, which is working on my accountability site. I could show you. Yeah. So like on my site, I put everything publicly, which I could, all the stats about me. So it could be weight, how many hours I sleep per day, or respiratory rates, or what music I'm listening to, or what books I'm reading to, what personal projects I'm working on, as well as all the work and sentiments, as well as you can get the complete, what do we say, transcript of the session over here only. And so hobbies, recently I'm playing like snooker every day, nearly hour or something. So just put it over there. And today we are going for a box cricket session. So that's why I added box cricket over here. Or else like I try different things with my hobbies. So yeah. And currently I'm reading uh, Make by Peter Levels. Does anyone know Peter Levels? Levels IO? You, can you?
So he has many side projects or like
Yeah.
very useful small softwares which are also like he uses very simple technology but the problem बहुत सारा solve करेगा.
Yeah. So like in short, he doesn't go by the framework. Rather, he'll just take one project and just hack something out of it. If it works, then he'll take it further. And if it doesn't, then the startup has crashed. And that's how he made like 13 projects a year. So yeah, I was a little bit inspired by him, and this is a book by him. Even if you're not an indie developer, it's a really great read. So if you just want to read. So that's whole thing about me. And one more thing will be that I am no ML developer or AI developer. I've been hacking this ML AI thing since last month, and this is just my journey, how I started. And I just wanted to entertain this thought of me that if I could create my own persona in various ways. I am like little bit into anime, if anyone is. I wanted to create the anime avatar, and that's how the complete thing started. And I started with the no-code tools, and then as all the itch we have as a developer, we just want to have something written, scripted, and somehow if you could add it in a code. So that's how I ended up learning this. And before anyone asks why am I taking this session before getting really deep into it, it is because that normally we forget the beginner's perspective, right? When you start learning and then you take it into granted that take it for granted that this is something everyone will know. So I have a very fresh perspective, and that's why I'm taking this session. So, uh, by the way, who knows, who has worked on stable diffusion? Has anyone worked on stable diffusion? Or ML or AI in general, even studied normally? Maybe. Is it like defining actual AI or applied ML or AI? The applied one. All right. So before I'll go into this, I'll just summarize that this won't be the only way to create images from text. This is one of the way, and this is the most accessible way, I suppose. Uh, I guess not. The most easiest way will be to pay and make models from make images from Midjourney, but obviously the most fascinating one will be this one. So I will be going through all the terminologies and everything as I understood, and obviously it will be in the transcript as well as these slides for anyone to grab. And yeah, so as I told that I'm a little bit beginner. So if anyone can intervene and knows a better understanding of a particular term, then they can explain me. Uh, okay. So done with the intro. I guess I have done. I'm done with this slide as well. So just wanted to have a disclaimer out there. And okay, so what was the inspiration? So as I shown my accountability site, what I'm trying to do is I want to have there is a hero section on the top, and that's where I want to have rotating images of myself in a different avatars in a different category. So what trying to do is create a prompt using OpenAI's API and feed it into the Colab notebook that I'm creating, and it will generate the images infinitely every day. And so that's how I'm planning to rotate the images on my site. So this is some actual use case what I'm working on. Uh, it is still under development, but I guess we'll be able to create something. And how this thought came by was from the Peter Levers only. I follow him on Twitter, and he was posting too much about the photo AI, and I thought maybe I could do it. So that's how I started. Then I stumbled into the overpowered. I guess anyone knows about overpowered by Varun Maya and Tanmay Bhatt. Tanmay Bhatt को तो सब जानते होंगे. Yeah. So he covers MLAI thing from the what do you say user's perspective, and so that's how I stumble onto something known as automatic 1111. So yeah, and Thakur is working in Hugging Face, and he recently created a tool which is Auto Train Advanced, and it makes very easy for a fellow developer to jump into applied ML or applied AI. It will be more like applied AI. So yeah, this is basic inspiration for starting with this. And my journey, how I started and how what I'm doing currently is like I started way I think a year back. Midjourney was launched on Discord. Sorry, आपके लिए awkward नहीं हो रहा ना? So. A year back, Midjourney started, and we could create the images on the Discord. Have anyone tried it? So yeah, it was really fun, and I really thought that we could not do it without this something like this. And just within 5 or 6 months, we were able to create this in our own laptop, given that we have CUDA supported GPU. Yeah, and then I started tinkering with automatic 1111 after watching the overpowered channel, and it was like it seemed to be really easy, but like automatic 1111 is a tool which is like still under development. So I ended up using something called Comfy UI, and which is more defined process, and you will understand when I'll show the demo. And about the coded session, I started working on Google Colab because my machine was not apt enough, and I could not do much things. I could not train models. Let's say like so I have train. I would not be able to train the model right now because it takes like too much of time. So I have already trained the model, but I will go through the code. And this is something what I have trained. This is a battle tank, and we will try the inference code on it and try to put it in different environment if time permits. So yeah, we'll start with automatic 1111, then Comfy UI, and then we will check the same thing in Google Colab by using code, and then we'll train the model, and then try to show this in the actual image. Uh, so, so this is like two path. What do we want to do? Like, do we want to go towards the terminologies, what is stable diffusion and blah, blah, blah? Or do you want to start with the code itself? Anyone can answer. One more vote I'll need. Okay, fine. Yeah, I'll try to. Just don't expect word by word because I was no hero in academics. All right. Chacha? All right. So I'll just skip couple of slides. We will get back on it. All right. So like just to give a little gist, um, these are some tools which are available for creating text to image models, text to images without using code. And I have tried the top two, and I'll just first show the automatic 1111 and then the other one. And by the way, I won't be showing the installation process because if I did that, then it will take too long. But I have added the installation link over here, and even for the Comfy UI. Also, I will suggest to go through the tutorial guide. It is very fun, so you will love it. Let's start with automatic 1111. Okay.
So automatic is good for mid journey as well, or only for stable?
Sorry, who is it? Ah, okay. Oi. Hi.
Automatic is good for mid journey also, or only for stable? Are you doing stable diffusion right now?
Yeah, I'm doing stable diffusion. Midjourney is not something open source, so it's just these are all the tools which uses stable diffusion
Yeah.
in general. And just to clarify, Midjourney doesn't use stable diffusion at all. They are using completely different their own proprietary code. Just tell me if Vanjay se પાછળ? Okay. All right. So as I told, the installation link is right over here, and just a little heads up that it will take a little time installing because every environment has their own installation guide. So I have already set up. And I also set up the alias. So that's why. Anyways, I can show the alias. So yeah, this is for SD. Stable diffusion for automatic 1111. No need to go into the details about it. I'll just run the SD. So as I told, this is still under development. So it doesn't. There is nothing written about loading, but you just have to wait a little while the model has been loaded. So you just have to keep tab on the terminal. Uh, Till then, we can go back to. Okay. So, what is stable diffusion? Can anyone explain, even roughly? I guess one of them could. Huh? मेरे को जो stable diffusion explain करें. हाँ. Yeah, please.
Text to image model created by
Oh, that's how you.
created by who? OpenAI?
It was created by Stability AI in conjunction with two other.
Yes. So essentially, they publish these files called checkpoints, and they are pretty huge files, and you can think of them as that is what the AI is. You can load that checkpoint in, different checkpoints for different results, and I think this is an open source product where
Yeah.
they don't expose how they build the model, but the model itself is available as the end result is available as open source, right?
No, this is completely available.
Even how they build the model.
Yeah, even how they build the model, and it is available long back. It is just that we have the processing capabilities for now, so that's how we created the complete checkpoints.
Yeah, and
Uh,
then recently they keep like every while they keep publishing newer versions of their checkpoints. Each checkpoint is,
yeah.
in my opinion, gives better results at lower computing costs. But then there is also they offer different levels of models as well. So there is an Excel model for which you need like a really big GPU, if I'm not wrong.
Yeah, so you are not wrong, and you are not completely right as well. They do provide checkpoints, but checkpoints are not the all and all. So you have multiple components into it. It is like complete pipeline. I'll explain later. But if you use proper VAE, or I'll explain the VAE and everything from what I get. And you can mix and match, and you can work it out under 16 GB of RAM or 12 GB of RAM. I know it might be overwhelming, and no way you will be running it on the local system, but you could train your own model, not the checkpoint one, but something called LoRa. So yeah, I'll explain in detail. But okay, so about what is stable diffusion, you are completely right according to the applied instructions. But what it does internally is what they have done for the checkpoints is that they have fit like multiple images with their captions into the couple of algorithms, and they have created something called latent space, which is pure noise. And which in if you know about neural networks, they are this is called weighted probabilistic model. So let's say a phone is connected to the adapter. So it will have more probability to be together. So that's how they have connected, but more statistically. So yeah, so this is what it is. So it has like two things. First is like language model. So what language model does is like it will transform text to the latent representation. Latent representation being the weighted graph thing, and it is like multi-dimensional. So it is not like 2D or 3D. It will have multiple nodes from each one. And about generative image model, it is like a, how can I explain it? So there is something called UNet, which is the core of the architecture, which converts the 512 by 512 images into 64 by 64, which will reduce the image to like 16 times lower, and then they are converted into the noise, which we could reproduce back into whatever we want using a couple of other parameters. Okay, so what is noise, right? Uh, it's not actually the noise, but assume something, you compress it so much that it reduces itself into something you cannot determine directly. Hmm. So that's why they, yeah, non-human readable or something like that. But that's why they call it latent. So the meaning of latent, oh, yeah, please. Okay, so the meaning of latent is nearly hidden or something like that, right? It's not obscure. So what it tries to do is you add the couple of text prompts, and it will relate each token. Each word is the each token, and it will relate each other, and it will try to create something related to that text. So that's how it is denoising itself. So at first, as Manan told, that they created checkpoints. So the checkpoints are actually the latent space, which is noise. And from the noise, it will convert back, the stable diffusion will convert back to something what we want using that text. So that's why these are two components. We also need the text as well as we'll need the images. Anyways, I'll continue back onto theory. Let's just check the stable diffusion thing. Okay, so like it has been loaded, as you can see, model loaded. So you just have to wait something like two minutes, depending on your system, obviously. All right. Mm, is there any volunteer? આમાં તો કોઈ technology नहीं જોઈએ. Anyone? Just tell me any prompt, anything that you would like to see. Pokemon riding a horse. Any particular Pokeball? Pick. Okay.
While eating popcorn.
Sorry.
Pikachu riding horse while eating sing chana or popcorn.
સિંગ જાના આપણે ટ્રેન કરવા પડશે ભાઈ. Lollipop. NSFW NSFW માં જતું રહેશે ભાઈ. કોટન કેન્ડી, પોપકોર્ન રાખીએ. સો ચાલશે, હવે લખી દીધું. These figured. So this is like positive prompt and this is negative prompt. Let's just try as it is. So kitlo time lagse, this will depend on the sampling steps, and the higher the sampling steps you will take, more crisp will be the images and more time the model will get to refine itself. So anyways, I'll just keep something like 25 for this. Let's keep something like this. Okay. So yeah, So this is the basic, like you can do other things as well. You can create image to image, or you can upscale the image. You can do many things using automatic 1111. I'm just showing this just to get you started. So the time it will take will be shown over here. And these are a couple of parameters. You don't need to worry about it. Just take in mind this. If you make okay, okay, અને તો રીલ આપી દીધી હોર્સ નહીં. So, like, if something like this happen, you can add multiple prompt over here. Something like high res for high resolution, Canon for camera, and can add something like photo for photo of Pikachu. Okay, so like so this is the positive prompt. As you can see, like it's not 100% result. એટલે પેઇન્ટર ક્યાં તો આર્ટિસ્ટને કોઈ દિવસ રિપ્લેસ નથી કરવાના આપણે ઇઝીલી, પણ બટ ઇટ વિલ ગીવ યુ ધ નિયર રિઝલ્ટ ઓફ ઇટ. હોર્સ છે પણ દેખાતો નથી એવું છે, ડબાઈ ગયો છે. ચલા નહીં ગયા, ડબ ગયા એકચ્યુઅલી.
So if you can remove eating a popcorn, then the horse thing be around?
Yeah, it could be, and there is also another way. I'll just show you. So you might have read about prompt engineering. કોઈ job માટે apply કર્યું? Okay, so like this is what it is. Like I am not a prompt engineer. Anyways, so there is couple of catch to it. Okay. So I am having an error like this. So that's what this is. Like it has its own shortcomings, and this is one of it. You won't be able to hold the RAM, and that's why, like, if once you create 2 or 3 images, if you are not working on GPU, a CUDA GPU or something like that, you might get out of memory or used up memory or something like this error. So this is still under ongoing development. But let's just not waste time here. You can try it at your home. WWF nahi એટલે ચાલે. Anyways, so a Comfy UI is doing the same task, but it is more layered, and it has a pipeline similar to what our code does. So let's just check that. Let's just take this prompt actually and try to work it out in there. Okay, I'll just close the stable diffusion, and same way I have added the alias for Comfy. Just ask if you don't understand anything. મને બી નહીં ખબર હોય તો હું કહી દઈશ.
So you are running this
On my on the M1 Mac.
using the GPU?
It has GPU. It has 8 cores, 8 GPU cores. Sorry?
Could you run it without any GPU at all?
No,
That's not possible.
that's not a possibility.
But why did it run out of memory was my question.
So so about the checkpoint, it loads the complete checkpoint in your RAM.
On your memory.
Yeah, on your memory. Yeah, and
Why is the number of images you generate a factor here, right? So you have the
yeah,
point
so
coded,
yeah.
then you keep generating images. You don't need to keep track of what happened before.
So that's what I was explaining. So this is under development tool, and it doesn't GC or something like that. So that's why it won't work right out of the box. But Comfy UI is more layered and more defined. So that's why you'll be able to see that it won't crash, but it will be definitely slower because it just GCs here and there. Hmm? हाँ एक सेकेंड जो હશે તો ઓકે સો this is the checkpoint actually stable diffusion checkpoint લખ્યું છે okay and here you can change the checkpoints as well sorry બીજું કઈ okay define check okay fine પાછો હું જઈશ મારી બુક પાસે હા ના વાંધો નહીં ના ચાલશે તમારા પાસે ટાઈમ હોય તો મારા પાસે છે okay so like this is basic terminologies if we cannot cover everything then you can check it from here this is again like not the definition it's just perfect perspective wise definition uh, so what we are working on is PyTorch right so there is multiple frameworks as like we work on Laravel or ROR or other frameworks this is same thing you can work on TensorFlow or JAX or PyTorch so we choose to work on PyTorch which is completely open source and then we come to the base model and the checkpoint so what Manan referred to before was not actually the checkpoint it was the base model so and that is what takes the most of the time કેમ કે બહુ બધા ઇમેજીસ ભેગા કરવાના ઓકે ઇફ you don't understand the Gujarati just tell me I just switch anyways so you have to gather too many images and create caption and that put it into some high supercomputer or something like that and wait if it completes so there is no percentage wise progress or anything like that so that's why they take too much time to create these base models and then comes the checkpoint okay so people like us let's say કે સિંગ ચના right now you want your own model કે જેમાં દરેક ફોટોમાં સિંગ ચના તો હોવા જ જોઈએ ભાઈ હા કોઈ ખાતું હોય કોઈ આમ ઉછાળતું હોય કશું બી right so that's when you create a specific model for yourself where seeing chana is a complete necessity so that is what is called checkpoint so people have created their own checkpoints generalized checkpoints so Juggernaut Excel che so which is base for like realistic photorealistic images similarly epic realism che પછી anything v3.0 che so which is specifically for anime images so you can use different checkpoints to get the different result with same prompt and same sampling steps the steps that we wrote like 25 use kare apne all right if there is any question just ask so this is the checkpoint yeah but like chat gpt we won't know if it is we are working on with the base model because it is a closed source so whenever they will update the chat gpt will update so in somehow it is checkpoint always એ લોકો update કર્યા કરે so it's just a checkpoint
Even in ChatGPT, you can choose, right? Which
yeah but that is the between the versions but you will never know if 3.5 is updated in itself
if you do API programming, platform
oh yeah
you can choose which
yes
model 3, 4.
yeah so yeah that could be written as checkpoint but we cannot define it as it is because like
They must be calling it something else.
yeah so like that is a little gist of it like this is PyTorch the framework and just as any other frameworks like it has different terminologies and different approach as well so in here they are using something called GAN and something called PEFT તો આ બધું સેમ મિડ જર્નીમાં નહીં હોય so even though it is doing the same thing it does the logic doesn't apply there એટલે જ the prompt that you use in stable diffusion would not work same way in the mid journey not even in the different checkpoints or the model. Okay. All right. Let's start with Comfy UI. Okay. So I'll have to zoom times in again, but just ask me if you have any questions. So this is more defined workflow, and that is what they call it, workflow. So you can take the workflow from other people as well. Just if you want to get a non-tech solution, the closest solution non-tech to the code will be this one. And you can mix and match as well. So I'll show it at the end, again if time permits. Anyways, so this is a checkpoint. Everything starts with the checkpoint. Then we will add the prompt. As it was in the A1111, this is the similar thing. This is the positive one, and this prompt will be the negative one. Okay, and uh, here is something called k-sampler, and it has multiple parameters. So what it creates the small image of your text, and then there is something called VAE decode, which will create the larger version of itself, and then you can see the image over here. Actually, okay. Let me start here. Just a minute. Normally you see the run thing over here, but you cannot right now. Let me just refresh. I think it might be resolution problem. Just a second. Let me start it in Chrome. Okay. And I change the browser. All right. પાછળ વંચાય છે? Okay, I'll just. Okay, fine. So I'll just cue the prompt and just explain. So the green thing here shows that where the current cursor is. So just a second. So this is the load checkpoint. Then we will move on towards the prompt. It will encode the prompt and feed it to the K sampler, and which in turn will generate the image out of the noise, as I explained before, and then it will create the 64 by 64 image, and then it will feed it to a VA decoder, VA encoder decode, and then it will create the large image and then save it in the save image. So right now it is at here, and as you can see, a little green thing over here, it is the progress. And if you cannot, then here it will be the in the percent. This is the terminal, by the way. We'll just have to wait a little while. Did anyone understand anything said was okay. Let's just take back this and so as I explained in the A11, this is the checkpoint. Here I only have one checkpoint. If you have more, then you can toggle from here. And this will be the prompt. Just a second. This will be the positive prompt. Okay. So this is the positive prompt. Hey. What did we write before? A Pikachu? Pikachu riding horse while eating popcorn. Okay. Then I added disfigured over here. So in the negative, you can add something what you don't want, something like disfigure or bad hands. Because if you know, Gen AI creates the worst hands and creepy hands. So that's why they have these prompts. And this is something called empty latent image. Just a second. If I can, I think the image will be created. Okay. So I don't know why today it creates like multiple images, multiple bottles, but this is something of an result of the last prompt. We can start again. Eating a popcorn. Okay, fine. Okay. So, anyways, so as you can see that it doesn't go back to the load checkpoint because it is already loaded, and now you can start working with the prompt, and it could go to case sampler directly. Now, there are two things left to explain. The one will be the empty latent image. So it could not, it should not be just the empty latent image. You can use the image to image as well. So let's say if you want yourself posing like Anil Kapoor in some photo, you could add the photo over here, and you will have the result of yourself posing as a Anil Kapoor, right? But for that, you will have to train the model with your own image. We will get back to it just in some time. So it has done with the sampling, and पाछू आ घोड़ा नहीं होता. So if horse doesn't come, then this is some little trick that you can do. What you want is horse to be emphasized in the while encoding the text. So you could add horse 1.2. So it will give more emphasis to the horse, or else just simply add pluses to it. So બહુ ટ્રાય નથી કર્યા મેં 5-6 ટ્રાય કર્યા છે. Yes, so it will just plus 1.2 is as good as 2 plus. Sorry, 1 plus. અને શું થયું યાર, એક સેકન્ડ. Okay. Okay. Anyways, so I'll just keep it running and we will move on to the code, I guess. ચાલશે કે is there any explanation remaining if you don't understand anything? Okay. Oh, by the way, I forgot to explain this. So like case sampler, here there is something called seed. It is something similar to seed everywhere. If you change this, the type of image will change, even though it is same prompt and same steps. So just like steps, there is also steps over here. You can add 20. And there is also one more thing that will affect the result, which is CFG. You can call it guidance scale. What it will do is you can have guidance scale from 1 to 21. And if you have guidance scale as 1, then it won't respect the the prompt. And as you go towards 21, it will respect text prompt more. So even if you added some image or something like that, just as I told that someone poses like an Anil Kapoor, it won't happen if the CFG is 21, for sure. It depends on the environment to environment. Here, in Confi, it is 8, but in what do we call? In A11, it is 7, and when you have to code it, then you will have to. Then it will be 7. Yeah.
Okay, if I entered a prompt for that and some external noises are there, so it will affect my output image.
Sorry, I didn't understand.
If I entered a text for generating an image, and at the checkpoints, if there is a noise, like human interruption or the RAM is not available, so there is an error in the output of generating image.
Yeah, like if there's no memory, what you will get? So it will just throw us out of the system. So even if we are using something from the Google, if there is no memory, then it will just outright tell you that out of memory, and the environment will shut off. Sorry, environment won't shut off, but it will exit the stable diffusion, and you will have to restart everything or restart the session at least, just like the restart that you do in your CPU. Uh, yeah, so there are more things that I could explain, but I'll just leave it up to you to learn from slide or something like that from the external. Like there are sampler, scheduler, how much value do we want to denoise or something, or more parameters. So this is like more basic version. There is also advanced version where you could add more parameters. Okay. हॉर्स तो नहीं जा रहा है. I don't know why. I think they haven't trained horse in this checkpoint. So that is also the case. The if particular base model hasn't been trained with, let's say, dogs, then you won't see dogs. Or let's say if it hasn't been trained with as much dogs than the cats, then it will show lesser dogs. So that's what it is. Like it will end up as a little noise. So that's why. Okay. Let's move on. So this was the complete UI. We will come back to Comfy, so I'll just keep it running. After like we'll need it after I show you the coding environment. Again, કેટલો ટાઈમ છે આપણા પાસે? પતી ગયો છે કે છે? હા, સોરી, હા બેઠા છો ને, બસ કંટાળો આવે તો કહી દેજો. પોપકોર્ન લવાય નહીં પણ બતાવશે ખરા એટલીસ્ટ. માનતું નહીં યાર મારું, અને થોડું શીખવાડવું પડશે, એટલે આપણે ટ્રેન કરીએ હવે. Okay, so like as I told you, like it takes time to train the model. So I have just clicked some of the images from this. I'll just shadow the process that I have done, and you just take my word for it that it works, right? And you can do it yourself. I have added all the code and links to the gist of the GitHub in this slides itself. So yeah, I'll just later show the URL, and if you want to follow at your own, you can. All right. So just a second. I need to get. Okay, so have everyone checked Google Colab or work with Colab before? How many of you? Okay. I'll just go through a little bit of onboarding. Hmm. Okay. So, second. I know today I'm losing my cursor now. Anyways, okay. So these are the terminologies. You can go through it, and I can take it off when there is a problem. So this is code demo, and so I have turned it in the three part. First is the inference code. Second will be model fine tuning code, and then using the inference code with the trained model. I'll start with inference code. So about inference, do anyone know about inference? What is inference?
We want to predict something.
Yeah. Okay. So yeah, we want to predict something, or we want to get at the end of the result. So that is what is inference. So from the checkpoint, we want to get at the result, right? So this is just the general term. Uh, okay. I will. So you can click on it and then you can open it in Colab. I'll just check in which profile I am. I guess this will do. Okay. All right. So I have ran already before, and I had added the prompt shading of a cute little baby elephant, and this is something what I got, right. Uh, so like I will run or let's just run the damn thing that doesn't work. This this prompt, right? So I'll just run and then explain what is Google Colab. Okay. So like this is Google Colab. Just how do I explain it? Okay. So assume that you have a terminal to someone else's computer in the cloud, where like you can run the basic commands and the Python code, right? So this is what it is. And about Google Colab, they have mostly imported most of the data science libraries beforehand. So if you don't want to, then it's cool. But so we don't want to take chance. So that's why I have imported the auto train advance, and I have set up ran the setup. So here, like you could create a complete walkthrough of your code. So, like if you want to add some text and tell that this is a code for blah blah blah, then you can do it. And you can also add the code just like I did here. Okay. So about the code until it runs. There is something called auto train advanced. As I explained before, I have wrote it in my inspirations that there's a person Abhishek Thakur who created this auto train advance. So how is it useful is that you don't have to go into the intricacies and the what do you say complex procedures of understanding what is VAE or what is PEFT or what is other terminologies. You can just use this auto train advance and create a pipeline for yourself. So yeah, and also one of the advantage it has is that upgrades all your libraries according to the need, because this is what we call like AI boom, and it is like every day the libraries are getting updated, so you need to get update all your libraries now and then. So that's why it is helpful. Okay. All right. So yeah, so this little green cursor, if you can see, tells us that where current our current what do you say the code is running. Um, okay. Let me just explain this. Okay, so this is something. This is a library diffusers, which is created by a group, Hugging Face. So it is a company which focuses mainly on, which is something similar to Google Colab, and they are creating library for diffusers, and they create multiple what do we say tools, just like text to image. They also create from image to image or for NLP and multiple things. So we'll just use this diffusion pipeline and auto encoder KL, and so these are all the libraries that I imported. One of them will be Torch. So we are using as I explained, that we are using the PyTorch framework. So that's why we'll need the Torch. And random is just to get the random seed. And this is a little hack. We use the chart library pyplot to show the image. Okay, so the image is creating just like 25 steps. Here it is 25 steps. So till then I'll just explain this. So this is like VAE. You don't need it in what do you say, in the best case scenario, but this particular checkpoint, or you will call base model, the stable diffusion XL, it has one problem with this diffusers, that that's why they have created this little bug fix. So that's why we had to add the different VAE, or else the default VAE will do. So what we'll create is we'll create a diffusion pipeline and use the floating point 16, because the CUDA supports floating point 16, or else if you have high RAM, then you can use 32 as well. So both of these parameter does that, and this is used safe tensors. So as you can recall, the model, they have the file type CKPT, but there is also one more version which is safe tensors, just like JPG and PNG, but safe tensors is more safe, more prone, less prone to attack or something like that. And this is CUDA. Okay. Okay. So this CUDA, this will be the device type. Um, let's say, okay. If you can see here, we are using the T4, and when we'll see in the resources. Okay, so I have Colab Pro, but if you don't have subscription, then also you will be able to get the T4, and you will get the like 12 GB system RAM and GPU. So as Manan asked before, that could it run without GPU? No, it could not. That's why we have to use T4 type of the system. And how do you change the system? Then there is in the above, you can change the run type, and here you can select between CPU, T4 GPU, and TPU. This is for Colab Pro, but we don't have to use that. Most of the diffusers library runs on T4 GPU. Just in case if it is not running, then it could be two scenario. Either you have coded it wrong, or there could be a bug. So if there is a bug, then you can just check the issues in the diffusers library. Okay. All right. So as you can see, a little checkpoint in, and it ran in 4 minutes, and okay, a little progress. ઘોડો ના આવ્યો પણ કઈ તો સ્કેટબોર્ડ જેવું આવ્યું. પિકાચુ પર પિકાચુ આવી ગયું છે ને. So yeah, so let's say we have ran all of this, but we just want to change the prompt. So we don't have to run the complete cell. What we'll do is just select this and run it, but let's just make it less prompt, and let's just remove popcorn. Popcorn બહુ complex લાગે છે. And I will add something all the prompt engineer will add, photo of a, and we can right click on it and run this selection. So we don't have to run this pipeline completely. We just run after the prompt. Okay. So this will be very quick. It will go through like 25 steps. As you can see, like it was running in my system, and it would take around 5 minutes. We have to uh, uh, get into theory, but we don't have to here. ઘોડો નહીં આવે સાયકલ બધું આવશે આખા ગામનું. Pikachu on a horse or something like that. ના પછી પિકાચુ બાજુમાં હોર્સ આવી જશે. આપણે લાસ્ટ ટાઈમ મારીએ, બહુ ટાઈમ વેસ્ટ નહીં કરો અહીંયા આગળ. એનીવેઝ, ઓકે, till then let's jump on to, yeah, I use Bard. Anyways, okay. Finally. Okay, so like not a wisdom, પણ અહીંયા શું થાય છે કે so stable diffusion is expecting some kind of a prompt, and even like the creators doesn't know why this happens, but like there are certain prompts which are more attractive to stable diffusion, and it will give more priority to it. And there is something like it will take, the prompt will be taken from left to right. So if we write Pikachu before, then it will take Pikachu as a priority. So there are chances that horse won't come, but Pikachu will always. So yeah. આ સેવ કરી રાખીએ આપણે. No, it will give the different result, but it is on us. It will give the different result because of this. This is a generator where we have added a different seed, right? I am taking a random out of 1 into 9 something digits. So it will have a different seed every time. So it will be similar to this, but not the same. And it could be wildly different. It won't be yellow horse next time, right?
You can fix the seed.
Yeah, we can fix the seed and have the same image appear again and again. Seed એટલે બીજ લા. Anyway, seed is something like it. Yeah, it is.
Every time we create random variable, like then we want to predict 57 as a random variable. So if we fix the seed now, we will get random variable as a 57. So seed is fix your random variable. So here that's why I use the random.
Yeah, it could be used for both the things. Let's say if I have created some image and I want to get it back, but I don't want to save the image. So what I'll do is I'll just save this configuration with this particular seed. So we can get this, we can have this result again and again.
Go in the same order. The
Yeah.
order will not change.
Have you,
Sorry?
so what I, when I tried stable diffusion, what I tried is I wanted to modified the prompt.
Yes.
So that gives me better idea. So like photo of a Pikachu on a horse with a random seed will give me different results, right? And I cannot give it a particular direction that I want it to go in this direction.
Right.
I can fix the seed and make small changes to the prompt. So instead of Pikachu on a horse, Pikachu with a horse or on horse or whatever. So like you can see how those small changes make
So
difference.
yeah, there are like multiple parameters you can do that. Let's say like if you are working from image to image, then the CFG thing, the guidance scale thing will play a big role, because it will define that how much of that particular image is been it inherits the composition and the color. So how much of that composition and color has been inherited to what do we say, the target, the resultant image.
So, seed થી આપણે randomness કે જે wide results આવે એને control કરી શકીએ છીએ.
Yeah, we can control the randomness not only from seed, but આપણે શું કરવું છે, let's say કે like I am cool with the prompt, I am cool with the every other configuration. I don't want to change the configuration, but I want similar kind of images but different images. So that's when the seed will come in and you can change the seed. And right now let's say કે આ prompt છે, હવે આ prompt મને ઘોડો તો આપશે જ હવે, but I'll keep the randoming the seed and it will have a different image.
Like સફેદ ઘોડો છે તો
પણ
brown આવશે.
હા એવી રીતે એમ. Okay. Like again, I am not a prompt king, so I cannot guarantee, but there are like multiple parameters to it. Yeah. Okay. So yeah, and like this is like very hazy image, but if you want to get more, what do we say, more refined image, then you can keep the same seed and use the inference steps, so that it will denoise it even more until you get the better images. Okay. So anyways, like you can hit me up if you have any questions about this code later on. I'll just go back to the another code. Just a second. Okay. Where is the slide? Okay. Okay. All right. So let's go towards the model fine tuning. As I told, like I won't go through the, I won't press run, but we can go through the code and we can check the result and we can use it for inference. Okay. All right, but let's go through the process of training an image. So let me go to the. All right. So I have like this kind of images. I have took these images with different backgrounds, and so what I'm using for model training is something called Rainbow, which is known for training a model with as less as 5 images. So yeah, so that's what I did. I took the minimal required images, if you can see. Okay, so this is of the random resolution. What we have to do is we have to convert it into 512 by 512, and if we are training with Excel, we can convert it to 1024 by 1024, because Excel is what it is like. Normal stable diffusion 2.1 used to have 512 by 512 image. Now stable Excel model has support for 1024 by 1024, so that's why. Anyways, so we just have to resize it for 512 by 512. Let me. Okay, so how do you do it? There are like you can use Photoshop or something like this, but there is this one site, Beadme, where you can just upload your images, and it will auto crop according to the keeping the image in center. If you feel that this should be the center, you can change the center a little bit. And okay, this is fine. And then you can rename it. I named it PNZR. Yeah. Okay. I didn't have to ask anyways. Okay. So I can start with one and save as zip. So like if anyone didn't get the context, there was a cheat code in San Andreas. So sorry. Why city ma ato pencil? Okay. So yeah, so that's why I named it PNZR. Okay. Also about why did I named it PNZR and not Penzer, PNZER? Uh, so like if you want to go through this, just go through my slide once because it will give you a little bit of extra information somehow. Once again. Um, where is it? Okay. Sorry, I will have to create the slides again. Just a second. Let me just show you. Okay. Just. Okay. This one. All right. So like these are. I have added it in the slide. These are all the tokens that has already been taken while training the model. So if you use something like Pan or Peter or something like that, then your training might be compromised because it already has a different context of that particular word. It has already been tokenized. So what you do is you use something unique, and so what I'll do is like I'll come here, then I'll just check if there is something called Panzer. If not, then I could use that particular token. Okay, uh, let's go back to where was I? Okay, here. Okay, so you will create 512 by 512 and then use this particular code. The inference code. Oh, sorry. This is the inference code. Oh, wrong code na dita. Okay. I'll just update it later on, but we can go through with the. All right. Okay, so this is the code to train your own model. Um, so like as we did basic upgrades, this is what we'll do. You don't need to do the Hugging Face update because I added it because there was a bug again and I had to go through it like an एक कलाक लगभग ट्राई करो पड़े तो Later I knew that it was because Hugging Face hub was not updated in Auto Train Advanced. You can skip it. I just like to keep it as it is, just to stay clear. Okay, so so this is taken from, as you can see, Abhishek Thakur's Colab notebook, but it was a little bit harder for me to read, so that's why I have distilled it and minimized it. All you have to do here is you can use the same notebook to train your own model. Just name everything something like this. So just like this tank, I have also created trained the model for Neil deGrasse Tyson, if anyone knows him. If you are into astronomy, then you will. So anyways, so I created for it, so I named it NDTYS, and these are a couple of other things, just like as we do in while inference, we will select the model name, then we will select the prompt. Okay, here you have to select the prompt that you want to use trigger, this is called trigger word. Like let's say if you use PNZR, right? Let's just change everything according to the Panzer. So I'll keep the project name Panzer. Similarly, I will keep the prompt PNZR. Okay. People also do like a photo of PNZR, and this is a class prompt. So now you told the model that you are working on PNZR, but it does not know what it is. So for classification, you also have to have a class prompt. So if let's say I am training Neil deGrasse Tyson, then it will be a person. Similarly, I am training battle tank over here, so I'll just write photo of battle tank. Okay. Better yet, I'll just put the space mark because like most of the words will have the space. This is one option, push to hub. Okay, push to hub. So just like in the code we have GitHub, here they have created something very similar to GitHub, that is Hugging Face. So what you have to do is like just like you have repositories, there are models over here, and sorry, where is it? In your profile, okay. There are models over here, so that like I have created for Panzer, I have created for NDTYS, that is Neil deGrasse Tyson. Then I tried to create one for GDGV, so which was like there was what do we say, Momento that we created before. I just wanted to try to create the model, but unfortunately could not because there was not a right class prompt for that. I wrote the plaque, but plaque could be interpreted in many ways and it has many shapes. So that's why I could not train it. Similarly, like there are multiple things that I have worked on, and let's go to PNZR. So just like in GitHub, there is also updation history, and this are something you call checkpoints. Okay, so this is a similar meaning of a checkpoint. In here, just take it as we have created a checkpoint for SDXL for our own model. So what I do is that I create checkpoint every 50 steps. So what we'll do is like we train the model for 3000 steps, but we don't want to wait for 3000 steps, or there is some sweet point when the model is at its best. So you never know that if it will be on 500 or it will be on 600. So what I used to do is I create the checkpoint for every 50 steps, and check the inference that how is the image for checkpoint 50, how is the image for 100. So that's why that's how you don't end up being lucky. Just ask me if there is any confusion. All right. This is Hugging Face, and you don't have to code in this. What you have to do is just go into the profile in these settings, in access tokens, and create your own access point, and you have to just add it in the in this collab in the HF token, right? So that's what you do, and then just write the repo ID that you want to have. You don't have to create the repo. You can just write PNZR2. Now we come to learning rate. Okay, so I could not explain you in complete depth, but learning rate is what defines the speed of your training. So as low as the learning rate, it will have a more clear idea, and your model will be more refined, but it will take more time. So you want to have also like if you have very low learning rate, then your model will be what they call it 2 fit, or what do you call it, like perfect fit or something like that. Huh? Overfitting, right? Yeah, it will overfit. What it means is that it will create your image as it is in the same pose as it is. So you don't want that. So that's why you have to have a good ratio of learning rate. For Dream Booth, one like just a second. So it is 10 exponential or 4 exponential of 10. Similarly, like this will be the learning rate. Then number of steps. So as I told you, like it will train for this particular steps. If I write it 3000, then it will train for 3000 steps, and it will take that much amount of time. So you have to maintain the ratio between these two to not take more amount of time and create a better image. And there is all these things. Let's not go into it. You can read it, and it's pretty easy to understand. So this is something that I have added, checkpointing steps 50. Okay, so for like every 50, it will create a new checkpoint. Only trade-off will be that your Hugging Face repository will be overcrowded because of saves, right? So you just have to take care of that. If you are deleting the repo, then you don't have to worry about it. Okay, so this is the code for training the LoRa, and this is the command for it. So we have added all the sufficient parameters, and we'll just feed it into the auto train Dream Booth, and we'll get the result. So last time I trained the Neil deGrasse Tyson, and you can use the same code for it. Okay, I'll update it later. And okay, so once the model has been trained, you can okay, you can access it in your Hugging Face models. Now you want to use the same model to infer and get the output. So for that, I have created a separate code. It is the similar code to the last inference without the train model. There are just a little difference. The difference will be just this line, load LoRa weights, and where I will refer to the our Hugging Face repo. Here, this first variable will be hub name, which will be Nightkill. That is my pseudo name in Hugging Face, and object name will be whatever we want. Let's say I already trained the Panzer, so let's try Panzer, P and ZR, right? I have to change the HF token because I changed it just before this session. I'll go into Hugging Face, go into settings, go into access tokens, copy the token and paste it over here. We'll keep this as it is. I explained you already, and the HF token will be saved to the environment variables, and let's just keep the process checkpoint false for now, and let's just see if everything is right. Okay. By the way, like if you want to see the results before, I have already trained with this checkpoints on. So what I do is I create a one image for every checkpoint and see what is the progress for the trained models. So I start with 50, increment by 50. Okay. So this was for Neil deGrasse Tyson. This was 50. So it was a female. Then for 100, it inherited a little hair where he has curly hairs. Then it started getting more what do you call inheritance of the composition. And here you can see a little bit of Neil deGrasse Tyson. Oh, I guess you won't have the context. Tyson. Okay. So here is what he looks like. And as we go towards more trained model, here he looks a little bit like him, and here more, and here very much like Neil deGrasse Tyson, and here where I stopped the training. So it was my mistake. I had to go on and on. If I have been till like 900 or 950, I would have gotten a better image of Neil deGrasse. Right? So anyways, we would be running that checkpoint, but let's run this one. Okay. Oh. All right. So we need to change a little bit over here. We change this object name to Panzer, but painting of a Panzer speaking won't be nice. Let's change it to Panzer battle tank in front of graffiti wall. And here is the different prompt here. Okay. Okay. So I have disabled the checkpoints, so it won't infer from the checkpoints, but we'll just see the last image when the complete end result. Anyways, like it will take some time. In that time, let's create the same thing in Confi UI. Just ask me if any questions. Okay. So for Confi UI, there is no integration for Hugging Face, so we'll have to take the safe tensor from there and then feed it into the environment. The models, just a second. Okay. In my profile, we take the Panzer, and in the files, so these are all the checkpoints. I have trained it till 1000. I think 950 is the most the best checkpoint. So I'll just update download that. If you want to download the end result, then you can download this checkpoint, which will be like 1000. And what I have to do is I will rename this PNZR2 because I already added one LoRa already. So I'll go to the directory of Comfy. This will be very similar in all the environments. There will be a models directory in there. There will be multiple directories. So these are each components that you can use. These are all the parameters that you can change. And so it includes the checkpoints, as we saw that checkpoint could be the SDXL base 1.0, it could be epic realism or anything v3.0. Similarly, there is something called control net. I won't go into it, but it will help you create image with the same pose every time with different person or anyone. And this is one for LoRa's. I have added the Panzer safe tensor already, but I will add the another one. This will be PNZR2, and if we go in here and refresh, then okay. Now this is a simple inference code, but what we want to do is we want to add one more node, and the node you can simply understand this like we want to load the LoRa, and here as you can see okay there is there are two, and we want the second one, and we could have the strength. So as good of a strength you will have, it will have more inference. We just keep it 1.0 for now and take it here. Okay, so this is the complete workflow, and we have to add the LoRa. So what we have to do is we have to add it in between K sampler and the model. So what we'll do is we will take this out and add this to model. It's simple drag and drop, and then connect it back to model. Now we also have to pass it through the text encoder, so that it will understand whatever prompt we write here. So that's why we will remove this and add it here, so that this clip will go here and this clip will go back to positive and negative prompt. Okay, so like this was just this much. So we have added LoRa already here, and now we need to change the prompt. Let's just write a simple prompt: photo of a Panzer battle tank. Okay, very simple. I'll just remove the negative one, and I guess we can run it. Okay. Okay, by the time we are waiting for this, we will check this. So it has not created any photo because we ran the complete thing with another prompt. Let's just run it with this prompt. All right. So I guess we are till near the end of the talk. If you have any questions, till then, both of them will do its work. Okay. So when you add the LoRa for the first time, the K sampler will take some time. This is because what LoRa is just the addition to the noise of the main checkpoint. So it will take some time merging the actual checkpoint and the LoRa. So that's why you must expect some more time, more than usual time here. Once you load the LoRa and run the result for one time, then it will take lesser time, less amount of time. Okay. So yeah, it's not the complete match, but it did what we told it to do. So yeah. And you can do the same thing here, but we have trained it for 1,000 steps. So you just have to change the CP upper limit, that is checkpoint upper limit, and it will run through the complete checkpoints. And you can figure out which model is best, and you can use it. Uh, so that's that. And here, okay. So yeah, it has better results, as you can see. Like this is something very similar to this. I guess we could tell that it is overfitting, right? So yeah, uh, I guess that's all. Um, Let me just blabber a little more. I just complete my slides. Um, where is my slide? Okay. So I showed the demo, and this is like what you can do further. There is something called in painting, where you can paint the part of the image that you already have. So let's say you have a photo of a person with very bad eyes. You can paint just the eyes. So you can upgrade it. Similarly, outpainting, let's say you have a smaller image and you want to make it bigger, but you don't want to zoom it. You just want to fill it with more continuation. So that's what is called outpainting. Then there is image to image. As I told you before, you can use image to image diffusion pipeline and use image and the text prompt to create the resultant image. And there is also one more thing. This is comparatively new. There is depth to image, where the model will take the depth of the image, as in like what do you call there is a depth, something called depth map. It will take that and create the image. So let's say you have two kittens sleeping, and you can change it to two tiger cubs sleeping, something like that. So yeah, these are the further steps you can do. And with that, I end my talk. Thank you. Yeah, so questions.